In example 3, we have multiplication of radicals, and the rule is going to be the outside with outside, inside with inside, and we can multiply inside with inside if the indexes match. So in this example here, if we take a careful look, we have to see what's on the inside and what's on the outside. So I've got my inside parts here, my root parts, and my root parts here, and they share the same index, and then the outside parts are going to be just these expressions here and here, and we can just multiply those together. So that's what I'm going to do. It's all connected by multiplication, so we don't have to worry about any distribution. So when I multiply these together, I get 12x. Okay, now I'm done with the outside. Again, like I said, there's no addition, so there's no distribution that goes on here. We only combine the outsides with outsides, insides with insides. Okay, so now I have the cube root. This is not the greatest color, but in fact, I'm going to change colors here. Okay, so I'm going to do my cube root in blue. So everything inside the cube roots here are going to go on the inside. So inside is going to be 2x squared times x, so x cubed. Okay, so now I've just dealt with all the inside parts. And again, it's all times, so we don't distribute this. So we have on the outside and inside. Now the last step is we do have to check to see if there are perfect powers in the inside, and there is. There's cube roots. There's a cube root, and there's a perfect cube on the inside that has to come out on the outside. So this becomes 12x. That extra x from the inside becomes x on the outside, and then we get the cube root of 2. So simplifying this, then we get 12x squared on the outside times the cube root of 2 on the inside. For B, the indexes don't match, so we can't multiply these together as is. But what we can do is we can actually do this as an exponential problem, or we could also power the index up and down using a ratio of outside and inside. So I'm going to show it two ways. So the first way looks like this. I can just write this as an exponent, and this is exponent 1/5 times exponent 1/2. They share the same base. If they have the same base, we can apply exponent rules. So we end up with 3 to the power 1/5 plus 1/2. And we can add those fractions together. It becomes 2/10 plus 5/10. And this becomes 3 to the power of 7/10. And we can just leave our answer like that if we like. So that would be one way to apply this. An alternate method would look like this. And this property we need to know before we apply it. But we can increase the index power by 2 as long as we increase the base power, the inside power by 2. So as long as it keeps a ratio of 5 to 1, we're allowed to do this. And we can do the same to the second radical, but this time I'm going to increase it by a factor of 5 on the outside and inside. And so I end up with the 10th root of 3 to the power 5, and that's the same as the square root of 3. We now have a common index. Notice that common index, if we take a look at the other method here, the common index is the same as a common denominator, and it's not some coincidence. They're completely related to each other. We get a common index to be able to multiply these together. We have to get a common denominator to add the exponents. So at this point then I can multiply inside with inside. I get 3 to the power 7, and there's my solution. And notice that the solution in exponential form has power 7 root 10 in the numerator here and the denominator down here. Okay, so these are the same solutions. These are two different ways of looking at it. One is doing it as a common index radical. The other one is using the fact that they have the same base, so we can apply exponent rules to that problem.